which means you're going to have to order them. You're going to have to figure out, first of all, let's say, you're going to have to figure out the wheat intercept and average enough, and that would be easy enough, whatever is 23, and 0 apples, and put that on there. And you have to add up the apple intercept, 20 and 0. And then you have to figure out the opportunity cost as you move along. BC isn't on the far left. You have to realize that you have to pick up BC, which I don't have correct here. But, everybody understand? There's one beginning step to arrange everything, and then, like I'll probably say to you, arrange these in order of opportunity cost, and you'll go BC, Nova Scotia, Quebec, Ontario, Alberta, Manitoba, Saskatchewan. Right, everybody? Because I want to get to the idea that you know how to arrange opportunity costs. Then you apply, and then I'll ask you questions such as I've already asked in the previous exam. What is the opportunity cost? Ready? One little step more difficult, but not particularly difficult because it really gets at the main idea. Shifts in demand and supply, same as before, different example. I just didn't now finish the kind of questions I can ask you on linear demand and supply. Later you'll say I can ask more, but right now this is all I want to ask. And let's notice something here. Okay. Another question I could ask you, and this is important. Listen carefully. What is the total revenue? What is the total, or another phrase is the same. What is the total sales of all the firms? And the total sales is in value. Here's the total sales by the firms. And here's the price they pay. This is the total revenue. Right? So total revenue, very simple concept, is equal to price times Q of that which is sold, right? So this is the total revenue. What is the total expenditure by consumers? At equilibrium, these are the same. At equilibrium, this is the total revenue of the firms. This is also the total expenditure of the consumers, right? But here, the total expenditure of consumers is this amount. So for us, right here, total revenue of firms is, this is assuming we're going to go with 150. 150 times 5,500, right? The total expenditure of consumers is 150 times 3,000. And what is the total expenditure by the government? It is 150 by the surplus, which is 2,500. So these are things we can do. You can easily do. There's examples for you to do to make sure you do them. This stuff is like that candy. You should be able to have no trouble with this at all. Okay, now, what's the purpose of this? The purpose of this is we can literally do this. You know, we're not some kind of bozos who are sitting around talking theoretically. Should we, let's say, what would this be? Suppose we were trying to stimulate the production of oil in the oil sands in Canada. And suppose the equilibrium price of oil was $120. And the government said, you know, we want to set the price of oil at $150 to stimulate those small-scale producers. There's always the story that I mentioned that they're going to produce cheaper. Leave that for the time being. Is this a good policy? Well, first of all, we would figure out the demand function. We would go out there and figure out the demand function. We would find that. We would figure out the supply function for the industry. We would figure out then at $150, we know what the equilibrium price and quantity is in the marketplace right now, which we can figure out. We have that. We can figure out the consumer surplus right now. We can figure out then the quantity supplied by these firms at $150. We can figure out how much consumers would pay. We can figure out how much it costs the government, and we can figure out the loss of consumer surplus. Right? So we can decide whether this is a sensible project. You can see here, we would lose a significant amount of consumer surplus. Consumers would lose $105,000. It's going to cost the government something to the tune of $2,500 times $1,500, $150. A huge amount. If this was the supply and demand, this would be crazy. We wouldn't want to do it, right? We would literally measure it. That's the way to do it. If Toronto wants, if we want something, this is how we do it. So again, how do we figure out the demand function? How do we figure out the supply function we'll deal with later? How do we figure out the demand function? We know. We would take a survey. You would ask a select group, statistically significant group, how much gasoline they would buy or oil they would buy at certain prices, and then you would translate that to a demand function for society as a whole. You would do that, or you would do something simple. You would say, we know another thing. If we knew at $150, because we had a couple of occasions to observe this, when the price was $150 for oil, 3,000 such and such were purchased. When it was 120, 4,000 were purchased. So at that point and that point, and with 2 points, we can estimate a linear demand function. Everybody? And that is the end down here. Estimate a linear demand functions from certain observations. This won't be on this exam, but I expect you to know how to do it. This is all about, here's the theory, here's how you apply it. Everybody? So not this exam, but make sure you can find a linear function. And the way I explained here, it's simple enough from a few points of reference. Okay? Good. Any burning issues? Now, we need to get to elasticity. This has two parts. First of all, one is the calculation of elasticity, understanding it and calculating it, and then the second is the application to taxation, this understanding. It's not just taxation. And it turns out elasticity is possibly the simplest concept in the course, is the concept that drives everybody crazy. All right? So there's one key concept to it, and I'm going to give it to you, and I'm going to expect that forevermore, as I say to the other class, I will allow you to come in here with strings on your fingers. And this string, for example, could be a string that when you look at it, when I ask you to do a question of elasticity, you look at that and you go, that green little string represents the secret of elasticity, right? And this little one here represents the secret of consumer surplus. And this one represents, you can do that. Because when you're, I don't want you to ever do a question of elasticity without stopping and going, I must remember. Otherwise you'll screw up all the time. All the time. You just sit here and spend 1 hour, 2 hours saying, this is the secret, and then taking you guys through it and having you screw up, and then having you screw up, and then having you screw up, until you remember that every single time you calculate elasticity, you remember one thing. Everybody? Good. So here it is. Elasticity is first articulated really by this guy Marshall in like around 1890. And what he wants to do is show what he calls the responsiveness of quantity demanded to quantity supplied. Now I'm going to show it to you in a specific way, which is in fact incorrect, in a sense, because it doesn't get the secret, the measure, but it gets the idea. And but you got to be careful with it, as we're going to see. All right, so I do it like this. Okay, something like this. All right, here is a demand function. Say this. This is a demand function for some commodity. It doesn't really matter what it is. Call it D0. And you'll notice at D0, here's the original price right here. Okay? Call this P0. And actually, I'm going to have another demand function right like this.
call this D1. Now, what is the difference between those demand functions? The difference is the responsiveness of quantity demanded to a change in price. Initially, they have the same price and the same quantity demanded, let's say. But then, price falls, say, to there, like that. And we have a different increase in quantity demanded. In the first case, you see that it increases like this. Now, it turns out my price change is the same in both instances. Right? In the second one, it increases like this. So we say D1 in this instance is more elastic than D0 because the quantity demanded has a greater response to the change in price. That's all that is. Okay, now, but this is, in that phrase, it's perfectly fine, and that's the way of defining it. We have to make it clearer, though, for reasons we'll see. And that's all it means. It's the responsiveness of quantity demanded, and intuitively you can see it's perfect. Here's the secret. We don't measure in absolute change. Elasticity is this. We do it as a percentage change. Right? So it's never the slope. The slope is the change in the quantity, the inverse of the slope. The slope is the change in price over the change in quantity. So what we basically want this. I'll show you, I'm going to continue with it. Elasticity is equal to, and I'm missing something, I want to say it's the responsiveness of quantity. It could be quantity supplied, it could be quantity demanded, whatever. From now we're going to worry about quantity demanded. It turns out to be more interesting. Change in price, right? But it's not just the absolute changes, it is the percentage change. That's exactly what it is. And the secret of elasticity is, under no circumstances to forget, you always calculate the percentage change. Now, percentage change is just the proportional change, as it turns out. So, now then, let's look at this. What do you think? What do you think a number? Now, elasticity turns out to be a pure number because it's a ratio of percentages. So what it is drops out. There's no unit to it. It's just a pure number. Secondly, it could be called, and I would use it this way, as it's a negative number. For demand, it's always a negative number. Elasticity of demand is, strictly speaking, unless we do something, which is what we will do, it's a negative number because if P goes up, Q goes down, P goes down, Q goes up, right? So it's a negative number. In first year, usually, and oftentimes it's in economics, you use it as an absolute value for the reason to see. That is, elasticity is really absolute value of the percentage change. It is the positive number, it is the magnitude of that ratio. So it is like this, strictly speaking, it is the absolute value. Now, I will forget sometimes because I just can't be bothered with that. I think of elasticity as negative, and I use the negatives myself because at certain times it's positive, it's interesting. For example, a given demand function, which is a positively sloped demand function, is itself positive, and that's nice to know. And some other elasticities can be negative or positive, as we'll see. But you guys can use it as an absolute value, and I always say, whatever it is, in absolute value, you have it as negative or absolute value. You see that in a minute. Okay, now let's just look at this diagram. I want everybody to figure out a number of the elasticity of the change in price from here to here, and the percentage change in price as the denominator, and the percentage change in quantity as the numerator and give me a number. So it's as simple as this. What do you think the percentage change in quantity there is? Now what does the percentage change mean? It means the change relative usually to, I'm going to ask you this. Your income just went from $1,000 to $1,100. What was the percentage change in your income? And you all know it's like 10%, right? You can think about this. This is one of the things. If I told you a mathematical formula for that, you're going to freak out. But everybody knows it's 10%. Similarly here, what you actually did is you took the change of 100 and compared it to the original amount, 1,000, and then multiplied by 100%. Actually, your mind probably can do that to get to 10%. Everybody? Good. So what is the percentage change here? Give me a number, somebody. What do you think? Yeah, 2025. Absolutely. Just look at it. Now this is key. The screw up is if you only compare the change. Now I say, now notice, the change here in price is like this. The change in price is like this, right? Now if I said, is this elastic or inelastic? Or what is this number here? People could go, well, let's see. This goes up by about, what would this call that, a 10? Or whatever it is. This increase here is twice as much as this increase here. So this, whatever this is half as much, or this is half as much as this, right? This is half as much as that. Whatever the number is like minus 0.5 or 0.5. Everybody? Wrong. Totally wrong. Because this here is, let's do it. 1, 2. No, we're not going to do this. We're not going to fiddle with this. Hang on. Okay, I think you're right. I would say, no, it's almost exactly 25%. What do you think, people? 25%. Everybody? Not difficult. Okay, then, what is the percentage fall here? So this would be plus 25% divided by, what would you say this percentage fall was? Well, give me a number. Is it 100%? Is it 10%? What do you think? We're not going to send you for an eye exam if we don't like your answer. What do you think? Okay, well maybe it is. Let's check it out just for, you know, here's one. There's another. Aha! Yeah, like what, 30, 33, everybody? So it turns out this is, over minus 33, strictly speaking, but we take the absolute value. So it turns out, notice, it's kind of the way we, we're going to call that, which is, I'll just say, notice this is less than 1. And we're going to find if that number, in absolute value, is less than 1 in absolute value, that implies that it's inelastic. Something is inelastic if the number, the absolute value is less than 1. Okay? So that turns out to be inelastic. But please pay attention, because I'm just going to keep running over you when we get it right.
Yeah.
Price fell by about 33%. Yeah, well, P0 is at the center of this. Oh, you're right, I'm sorry. I wasn't thinking. You're absolutely right. That's what I'm really sleeping on me. Blanking, because when I first thought about it, I thought it was about 5%. Yeah, she's right. I'm not thinking it. This is a total mistake. It's relative to the original P0. Everybody? Everybody? So this is actually 25%. So it turns out to be interesting. It's probably very close to 1. And this is, we call this unit elastic. If the number is 1 in absolute value, it's called unit elastic. Now, this is really important because most people will look at that, and no matter how many times I tell you this, you're going to go into exams, and I'm going to ask you this in many, many different ways. I'm going to twist you, turn you, and all the time you'll always make mistakes unless you just land at your feet by going, got to look at the percentage change, got to look at the percentage change. Right? So this turns out to be unit elastic, as it turns out. Right? About unit elastic. Okay. Now what about the other one? What do you think the other one is? The other one would have this is something, question mark, divided by minus 25%. So what do you think this increase here is in the percent? 100% did you say? Looks pretty good to me. So this is plus 100%. This number would be strictly minus, I'll put it as minus 4, which is equal to 4. Again, I would use minus 4, but we use 4. And that's greater than 1. And we call that elastic. Right? It's elastic. The force stretches it along. If the force doesn't stretch it very much, it's inelastic. So definition. Elasticity, something is elastic if the percentage change in quantity demanded in response to the percentage change in price is greater than 1. It is unit elastic if the percentage change in quantity demanded is exactly the same as the percentage change in price. Then inelastic if the percentage change in quantity demanded is less than the percentage change in price. Everybody has all this. All right, now, let's get rid of that. Is elasticity along a demand function constant? It's a straight line, it's a linear function. A linear demand function is elasticity constant. Yes?
No, because the rate of change is the same, but the proportion that it is in reference to would be different depending on
The slope is constant, but the percentage change is not the same. So this is fundamental. Linear demand functions do not have constant elasticity. Now, usually later in the class, you will look at that and you'll kind of say to yourself, that is an inelastic demand function, relatively speaking, but is by no means an inelastic demand function all by itself. As we're going to see, this, every linear demand function, I'll just draw one like this here, along with this thing. Because I want it like this. All right. Okay. This demand function, let's look at it very carefully. It does not have constant elasticity. Let's start here. I'm going to have the price fall like this. And so we have that's 1. That's 2. Everybody? Now, P0, P1. What do you think? Now here, let's see. A fall in the price of this amount, let's say this is this drop here, I'll just say this fall is $2. Okay? This is a fall of $2, and this is an increase of $1,000. Not fully relevant. What is the elasticity? Right here. Give me a number. What do you think the percentage increase in quantity demand is? Give me a rough number. 40, 50, I'm going to say, yeah, let's say 40. I'd say 40, almost 50, right? That's okay, 40. So we've got plus 40% divided by, remember, we're always a percent. What would you say the percentage decrease in price is? Again, you guys are treating this like, my God, you've got to figure it out. Is it a fall in 15.265%? What do you think it is? 10%. Everybody? Very comfortable. 10%. Minus 10% implies, talking about absolute value, elasticity is 4. It is elastic. Okay, good. Let's do the same thing again. Let's have a fall, let's take a price here, right here. Okay, and let's have it, actually, I better put that back, sorry. Stick that back where it was before. And let's do this price here, from here. Let's have exactly the same fall. What does that look like? Let's have it fall by this amount and it goes up by that. Notice everybody? It falls, the price falls by the same, not quite. Okay, the price falls, I should do just a little bit here. Roughly by exactly the same amount, and the increase is the same. So once again, we have $2, falls by $2, goes up by 1,000. So the slope is the same. We know that. It's a linear demand function. What is the elasticity of this? What do you think the percentage change in quantity is? Now here it's about 10%. Everybody? Plus 10%. Divided by, what would you say the percentage fall in price is? 40, maybe even 50. I'm thinking it's more, so 40, I would say 40, you're right. 40%. Okay. 0.25. The elasticity is totally different, right? Elasticity is totally different. Okay. Next. It turns out, this is interesting, elasticity measured in percentage change is not only the best way to measure elasticity because it avoids, the absolutes can lead you into trouble. The same quantity change in response to the same price change gives you very different change in total revenues in the scene. And also, if I said to you, the price of a can of Coke, which is normally $1, falls by 50%, you can imagine that it'll change the